Hello and welcome to a new video on ICSE physics. So this is a continued video in the series of lectures for ICSE physics 2026, and in this video I'm going to discuss a few previous year questions and in addition to it a few extra questions that I found interesting and important in the context of board exams. Let's get on with it. To view this video and to have a clear understanding of what I'm saying, please go over the video on the theory for chapter 2, work, power, energy, on this same channel. If you have done that already, let's get on with it. So question number 1, when a bell fixed on a cycle rings, then the energy conservation that takes place. It's a very common and very expected question for ICSE, in which they ask you about the kind of energy conservation that is taking place in different instruments, objects, phenomena, or machines. So here the phenomena is the ringing of a bicycle bell. So the energy conservation is very simple, which we know it is mechanical to sound. You physically move the bell. And inside the ringing happens also because of vibrations, the vibration of the particles of the parts hitting each other. Yes, if you have noticed, if you have been curious and opened a bell in your life, you must have seen that. Yes, and then vibration of the sonorous materials generates sound. So it is very simple, mechanical to sound energy. Number 2, the energy conservation in a washing machine is what? It is electrical to mechanical energy. A washing machine runs on electricity, and what it does, it replicates the motion of a human. How does a human wash the clothes? By his hands, by moving the clothes, by beating it with a stick, something like that. So if you have seen a washing machine, it imitates that motion, it moves the clothes, correct? So electrical to mechanical. Yes, moving on. When the speed of a moving body is doubled, its kinetic energy becomes what? When the speed of a moving body is doubled, its kinetic energy becomes what? So we know that the formula for kinetic energy is half mv squared, where m is the mass and v is the speed, correct? Now they are saying that the speed of the body is doubled. The speed of the body is doubled. So half m 2v squared. I hope I'm clear. The speed of the body is doubled. So the kinetic energy now will be half m into 4v squared, 2v times 2v, correct? So if you take the ratio kinetic energy nu 2 by kinetic energy 1, it comes out to be half m 4v squared by half mv squared. This comes out to be 4. So the speed of a moving body is doubled, the kinetic energy becomes 4 times. I hope I'm clear. Moving on. You see, such simple questions they ask in ICSE, and it gives you very easy marks. So just for writing mechanical to sound energy, you will get 1 mark. You will be awarded 1 marks. Yes, moving on. Work done by the force at any instant is. So it is a bit tricky to think of. What does it mean? The work done by a force at any instant. What does it mean? Instant means instant, right? There is no time delay, right? So you can say that the time duration is 0, tending to 0, very small. In that time duration, the movement of the body is negligible. In that time duration, the movement of the body is negligible. So the work done by a force at an instant is 0. Yeah. Now that you know it, you will. I am sure that you won't forget it. What do I mean? Let me go through the problem again. They said work done by a force at any instant. What do you mean by instant? Instant means without any time gap, without any time duration. Yes. So when you don't allow for a time duration, there would be no displacement. And if there is no displacement, there is the work done by the force is 0. Yes. So the work done by a force at any instant is 0. I agree, and I very much agree with you on the point that this question could be better formed. Yes, it could have been asked in a better way, but in the case of ambiguity, we'll go with what is the most common answer. Yeah, and this is the most logical answer, given that the question is framed in such an ambiguous way. Yeah, so we will write it as work done by a force is 0. I hope I'm clear. Let's go ahead. For 2 marks, Sumit does 600 joules of work in 10 minutes and Amit does 300 joules of work in 20 minutes. Calculate the ratio of powers delivered by them. So here they are saying there are 2 individuals, Sumit and Amit. Sumit does a work of 600 joules and the time he takes is 10 minutes, right? And Amit does 300 joules of work in a time duration of 20 minutes. Calculate the ratio of powers delivered by them. We know that power is what? The rate of work done. The rate of work being done is called power. So let's calculate power due to Sumit is what? Work done by Sumit upon time, rate of work done, correct? So it is 600 by 10 joules per minute. For Amit, the same thing is power delivered by Amit is work done by Amit upon time, which is 300 by 20 joules per minute. In these kind of questions, mostly you must be very careful about the units that they have mentioned in. Yeah. So here, since I am going to take the ratio of Sumit and Amit, just make sure the units are same. Here we have joules per minute. Here also we have joules per minute. So we are good to go. Calculate the ratio of powers delivered by them. I need power of Sumit divided by power delivered by Amit is what? We just calculated it. It is 600 by 10 joules per minute divided by 300 by 20 joules per minute, which comes out to be 600 over 300 times 10 times 20 is 4. So the ratio of power delivered by Sumit to that of Amit is 4. I hope I'm clear. Just this much and you score 2 marks easily. What is important to be noted here is the definition for power, which is the rate of work being done. I hope I'm clear. Let's move on. This is the same question. You may use this as a practice question. Practice it. Yes, such kind of questions repeats oftentimes in ICSE. So please go over it. Yeah, it is based just on the definition of power, the rate of work being done. Let's go to the next one. 2 identical marbles A and B are rolled down the path 1 and 2 respectively. Path 1 is frictionless and path 2 is rough. Which marble will surely reach the next peak? So as you can see, the peaks are almost at the same height. Yeah. So for the sake of generality, we will assume that they are at the same height. Yeah, we will assume that they are at the same height. Now, which marble will surely reach the next peak? Which marble will reach the next peak? How do you know it? How do how do you evaluate this kind of questions? Number one, the path 1 is frictionless. Friction is something which opposes motion. Friction is something which opposes motion, which causes losses to happen. Yes. Path 2 is rough. Rough means it has friction. Rough means friction. So out of the two paths, path 1 and path 2, which path will have no energy losses? Yes, you are right. It's path 1. Path 1 will have no energy losses. And path 2, since it is rough, there will be energy losses. There will be friction which oppose motion. Correct? So in the path 1, the marble A rolls down, and since there is no loss of energy, it's going to climb up to the same height and reach the peak. But in path 2, which is rough, what will happen? Marble B will roll down, but it won't be able to climb up to the same height because there has been some energy loss of marble B while traversing path 2 on account of path 2 being rough, path 2 having friction. Yes, so which marble will surely reach the next peak? Marble A. Next, along which paths the mechanical energy will be conserved? I just said it right now, right? Friction is something which causes losses to happen. Yeah? So the mechanical energy of the marble, which is on account of position, that is the gravitational potential energy, and motion, which is the kinetic energy. Yeah. So there will be losses on the account of friction being present in which path? Path 2. So mechanical energy will be conserved for the path in which there is no friction. So it is path 1. Next, along which path is the law of conservation obeyed? Yeah, it may be a tricky question to you. You may be thinking, part B and part C are same. No, there is a subtle difference. Yeah, the second question, they have asked you just the mechanical energy, nothing else, just the mechanical energy, right? So along which path the mechanical energy will be conserved? Path 1, because path 2 is rough, right? So there are losses happening in path 2, but the law of conservation of energy is universal law. It applies to everything. It accounts for the losses also. Yes, so the law of conservation of energy is obeyed for both path 1 and path 2. I hope I'm clear. If not, please go over my the video on work power energy. They have explained this law properly. Let's move on. Name the physical quantity obtained using the formula U by H, where U is the potential energy and H is the height. We know that the gravitational potential energy has a formula mgh, right? And now they are saying I want U by H, so it comes out to be mgh upon H. It is mg, which is nothing but the weight of the body, right? Weight of the body. Correct. Calculate the power spent by crane while lifting a load of mass 200 kgs at a velocity of 1.5 meter per second. We know the formula. Power delivered is force times velocity. Yeah. If you are confused about the formula, please go over the theory video on work power energy. There I have had a detailed derivation of P equals F times V, which is force into velocity, and the power generated will come out to be, what is the force? The force applied by the crane is to lift the mass of 200 kgs, right? So the force applied by the crane has to be equal to the weight of the body. Yeah, so the force is 200 m into g. Yeah, according whatever the weight is, I'm applying the force to lift it up. So weight of the body times the velocity, 1.5 meter per second. Yes, So how much do I get it? 200 is in kg, g is in meter per second square. So 200 into 10 into 1.5, I get kg meter per second square into meter per second. It's how much? It is 3000 watt. I hope I'm clear. Part C. A car of mass 120 kg is moving at a speed 18 km per hour and it accelerates to attain a speed of 54 km per hour in 5 seconds. Calculate the work done and the power of the engine. A car of mass 120 kg is moving at a speed of 18 km per hour and it accelerates to attain a speed of 54 km per hour in 5 seconds. Calculate the work done and power of the engine. So let us solve it. Yeah. So there is something called work energy theorem that we had learned in the last chapter, in the last video on the lecture of work power energy. So now I have a car having a mass of 120 kgs. Yes, it is moving at a speed. So the initial velocity is what? 18 km per hour. 18 km per hour. Yeah. So you may convert it to meter per second. SI units is always a good idea. I hope I'm clear. 1 kilometer is 1000 meter and 1 hour is 3600 seconds. 18 times 2, 2 times 5. So the initial speed is 5 meter per second. And the final speed after a duration of 5 seconds, 5 seconds of acceleration, the final speed will be 54 kilometer per hour, which is 54 times 1000 meter, since 1 kilometer is 1000 meter, and divided by 3600 seconds. 1 hour is 3600 seconds. Yeah, getting it? I know that 6 times 6 is 36, 6 times 9 is 54, 3 3s are 9, 3 2s are 6, 2 5s are 10. So it is 15 meter per second. Yes, so the final speed is 15 meter per second. The final speed is 15 meter per second. So I know by the work energy theorem, that the work done on the car is the change in kinetic energy. Kinetic energy final minus kinetic energy initial. The work done on the car is the change in kinetic energy. So kinetic energy final is what? I know that the formula for kinetic energy is half m. The final velocity is v squared minus the initial speed is what? U. So u squared. It comes out to be half m v squared minus u squared. It's what? It is half times the mass. Mass is 120 kg times v squared. 15 squared is 225 minus u squared. 5 squared is 25. Yes. So the work done in this case is what? The work done is equal to 200 times 120 by 2, which is 12,000 joules. Yeah. Now they are asking work done, you have calculated 12,000 joules. The power of the engine. How do you calculate the power? The power of the engine is nothing but the work done per unit time. I know that the work done is 12,000 joules and the time taken is 5 seconds. So it comes out to be 5 2s are 10, 2400 watt. I hope I'm clear. Yeah, so this was a basic consequence of the work energy theorem, a basic application of the work energy theorem. If you have been given the initial and final speeds, yeah, so you may just calculate the work done by the difference in kinetic energies. Yes, I hope I'm clear. If I'm not, please go over this video once again and see how I have done the question. Yeah, if it's still not clear, please go over the last video of the theory in which I have derived the work energy theory. Okay, let's move on. Okay, a satellite revolves around a planet in a circular orbit. What is the work done by the satellite at any instant? So there is a circular path and there is a satellite orbiting it. You can see that the displacement of the satellite is always tangent to the circle. The displacement of the satellite is always tangent to the circle, and the force acting on the satellite is always radially inwards. It's a force of gravitational attraction. The planet is attracting the satellite. Yes, so the angle formed between the force and the displacement is 90 degrees. So the work done in this case will be 0. Yes, good. Next, give an example each for the following energy changes: chemical energy to electrical energy. Yeah, it's a simple cell or a battery, whatever. The chemicals stored in the battery generate electric potential. Yes, good. Electrical energy to sound energy. Where have we seen this? It's a doorbell, right? So we use an electric doorbell. We press the switch and the bell sounds. Okay? So electrical energy to sound energy. One more example can be what? A loudspeaker, right? So we speak into the mic. The sound energy is converted into electrical signals. Those electrical signals is again in turn, converted into sound energy. Yes, I hope I'm clear. So let's get on with the next question. Crane A lifts a heavy weight in 5 seconds. Crane A lifts a heavy load in 5 seconds. Yeah, the time taken is 5 seconds. And a crane B does the same work in 2 seconds. The time taken is 2 seconds. Let's say the work done by A is W and the work done by B is W. They are the same because crane B does the same work. Correct? Let's say the power generated by crane A is what? Work done upon time, work done upon 5. Yes, and the work done and the power generated by B is what? The work done per unit time, which comes out to be W upon 2. Let's see the ratio. Yeah, power generated by crane A upon power generated by crane B is what? W by 5 upon W by 2, which comes out to be 2 by 5. Yes, I hope I'm clear. It follows from the basic application of the definition of power, which is the rate of doing work. I hope I'm clear. Okay. Two bodies A and B of masses in the ratio 5:1. There are two bodies A and B. They are saying their ratios, their masses are in the ratios. Let's say MA upon MB is equal to 5 upon 1. This is what they are saying. Yeah. So by cross multiplying MB, do I get MA is equal to 5 MB, and the kinetic energies are in the ratio 125:9. The kinetic energy of A by kinetic energy of B are in the ratio 125/9. So the kinetic energy of A equals 125/9 times kinetic energy of B. So these two information is what we have attained from the question. Yes, so let the mass of object A be ma, right, and the speed be va, and the kinetic energy be kinetic energy A. Similarly for B, let the mass be mb, vb be the velocity, and kinetic energy of B be keb, right? So using these two equations, I know that kinetic energy of A can be written as half ma va squared, and using all of this, I know that kinetic energy of B can be written as half mb vb squared. Yeah, so substituting the value of kinetic energy A, the expression of kinetic energy of A is what? Half ma va squared equals 125/9. From here I am substituting the value of kinetic energy of B, comes out to be half mb vb squared. Yeah, so let's simplify. This half gets cancelled with this half, right? ma upon mb times va squared by vb squared is equal to 125/9. I hope I'm clear. M comes down and vb square comes down, right? Now I know the value of ma by mb. I know the value of ma by mb, which is 5. So 5 times va by vb squared is equal to 125/9. This 5 gets cancelled, and I get, let's take the square root on both the sides. va by vb, it is the square root of 125/9, which is 5/3. So the ratio of their velocities is 5:3. I hope I'm clear. This is 25 and not 125. Yeah, let's move ahead. Yeah, it looks a little bit mathematically rigorous, but it is not. Yeah? And this simple, it follows from the simple application of the expression for kinetic energy. Yes, and you have scored 2 marks easily. Let's move ahead. A body of mass 10 kg is kept at a height of 5 meters. It is allowed to fall and reach the ground. So they are saying there is a body of mass 10 kgs and it is kept at a height of 5 meters. It is allowed to fall and reach the ground. What is the total mechanical energy possessed by the body at a height of 2 meters, assuming it's a frictionless medium? What is the kinetic energy possessed by the body just before hitting the ground? Fine, let's do it in a generic way. What is the speed at this point, topmost point, when it was just released? It is 0. So what is the kinetic energy? Kinetic energy is half into mass into speed squared, but speed is 0, so kinetic energy comes out to be 0. What is the potential energy at this point? It is, yes, mgh. I know the mass is 10, g is 10, and h is 5 meters, so it is 500 joules. Correct? Good. Now they have asked us, what is the total mechanical energy possessed by the body at a height of 2 meters? So the body has reached here the height is 2 meters, right? It will have some speed. It will have some speed here. Yes, we may either go ahead to calculate the speed and the eventual kinetic energy calculations, or what we can do is note that they have said it's a frictionless medium. It's a frictionless medium. What do I mean by that? There is no friction in between, so there is no energy losses happening. There are no energy losses happening, right? So the mechanical energy of the body will be conserved, right? There is no friction to deplete the mechanical energy, so the mechanical energy will be conserved. So the total mechanical energy at a starting point will be same all throughout its trajectory. Let me repeat it. The total mechanical energy of the mass of the body will remain same all throughout its journey, right? So if I am required to find the total mechanical energy here at this point, it is the same as anywhere else in the trajectory, anywhere else in the trajectory. So let me take it up to be the easiest point, which is the starting point. Total mechanical energy at this point is what? The kinetic energy plus the gravitational potential energy comes out to be 0 plus 500 joules. It comes out to be 500 joules. The total mechanical energy of the body is conserved. That means everywhere it is the same. So it is same here as well. 500 joules is the answer. Yeah. Now they are asking, what is the kinetic energy possessed by the body just before hitting the ground? What is the kinetic energy possessed by the body just before hitting the ground? So just before hitting the ground, the object is here. The speed is something, let's say v. Kinetic energy is something that I want to find out. Let's say it is KE itself. What is the gravitational potential energy here? It is 0 because the h is 0, the height is 0. Yeah. Let me evaluate the total mechanical energy, which is the sum of kinetic energy and potential energy. It comes out to be kinetic energy itself, because the gravitational potential energy just before hitting the ground is 0, right? Now I know that the total mechanical energy of the body is conserved for the entire duration of journey, for the entire trajectory of the body. So it is also equal to 500 joules. I hope I am clear. Yes, so you have to explain this understanding of yours in the board examination in proper words. Yes, I hope you can do it. Yes, and I know you will do it. Let's move ahead. State and define the SI unit of power. We know it. What is it? It is watt. It is watt. What is it? It is watt. Yeah. So how is the horsepower related to SI unit of power? So I know that there is something called 1 HP also, 1 horsepower, and which is equal to 746 watt. All of this has been covered in the last chapter. Yeah. State and define SI unit of power. The definition of units comes from the definition of the physical quantity itself. We know that power is what? The rate of doing work. The SI unit of power of work is joule. So 1 watt is defined as follows. When 1 joule of work is done in 1 second, when 1 joule of work is done in 1 second, the power generated or developed is called 1 watt. Let me repeat it. When 1 joule of work is done in 1 second, the power developed is 1 watt. Let's move ahead. State the energy changes in an electric iron and ceiling fan. We know this. It is electrical to heat. Ceiling fan is what? Electrical to mechanical, or a bit more precise would be kinetic. Yeah, I don't think it requires explanation. Let's move ahead. State and define the SI unit of power. How is the unit horsepower related to SI unit of power? This we have already seen. It's a repetition. So it's a practice slide. Please go over it because this kind of questions are very, very common. Yes, common and easy and very high scoring also. Just by solving these two questions, you get 4 marks. Yeah. Let's move ahead. Name the process used for producing electricity using nuclear energy. So we all know that the name of the process is called nuclear fission. What do you mean by it? Yeah, just remember it. The process used for producing electricity using nuclear energy is nuclear fission. And then later when we study the modern physics, which is also in the ICSE syllabus, you'll be having a better understanding of what fission is. Okay, let's move ahead. A boy weighing 40 kgf climbs up a stair of 30 steps each 20 cm high in 4 minutes, and a girl weighing 30 kgf does the same in 3 minutes. Compare number A, work done by them, and number B, power developed by them. Let's do it for the boy first. Boy. Or you know what? We always say ladies first, right? Let's do it for the girl first. Yeah. So the girl is weighing 30 kgf, right? And she goes up a stair of 30 steps, each 20 centimeter high. So they are going up a staircase. Each step is 20 centimeter high, and there are 30 such steps. So what is the total height that they have attained? Total height is 30 steps, and each step is 20 centimeters. So it is 600 centimeters. Yes, they have gone up a height of 600 centimeters. Yes, so the work done by the girl is what? Work done by the girl is against the force of gravity, which is her own weight. Yeah, the force applied by her is her own weight. The force carried by her is her own weight. So it is 30 kgf times the displacement. The displacement is upwards. They are going up 600 centimeters. The 600 centimeters. The work done is positive because she is carrying her weight. The force applied is upwards, and displacement also is up in the same direction. It comes out to be 18,000 kgf centimeters. 30. Correct. And the power generated by the girl is what? The rate of doing work. The work done by the girl upon time. The work done is 18,000 kgf centimeter divided by time taken. The time taken is 3 minutes by 3 minutes. It comes out to be 6,000 kgf centimeter per minute. Yes, let's do the same thing for the boy. The boy goes up the same step. Yeah, so the work done by the boy is in carrying his own weight. The weight is 40 kgf. The 40 kgf times the height. Height is again 600 centimeters. So the work done is 24,000 kgf centimeters. I hope I'm clear. And the power generated by the boy is the work done by the boy upon time taken by the boy. It's what the work done by the boy is. We just calculated it to be 24,000 kgf centimeter. In what time? 4 minutes. So it is 6,000 kgf centimeter per minute. Now can you compare the work done by the boy and the work done by the girl? Yes, you can. It is 24,000 upon 18,000. The power generated by the boy 6,000 by 6,000. The power generated by the girl. Yes, while comparing, just make sure the units are same. Kgf centimeter per unit, kgf centimeter per minute, kgf centimeter, kgf centimeter. If you have done that, you are good to go. I hope you can complete the question. Yes, Please do so. Easy 2 marks, right? Let's move ahead. Okay. How is the work done by a force measured by when the force is in direction of displacement? This is the question from the last chapter. Yes, how do I do it? Work done by the force measured when the force is in direction of displacement. Number 1, we know that when they are saying that there is a force acting and displacement is also happening in direction of the force. In direction of force, the work done is just a simple multiplication of force and displacement. Yes, the second case is when the force and displacement have an angle between them. The force is at an angle to the direction of displacement. So there is a mass, it is moving to the S, displacement is S. Yes, and they are saying there is a force acting on it at an angle, not exactly in direction of the S, it has an angle. We know that work done for this case is what? Force times displacement times the cosine of angle between them, which is theta. Work done is Fs cos theta. You all know this. You all know this. I am very sure. Say the energy changes happening in burning of a candle and steam engine. Candle is what? Chemical to heat. Chemical to light. Yes, the main purpose of a candle is to give light, right? So we will write it to be chemical to light. Yeah, we know that heat is being generated, but you won't mention that. You can mention it, but the main primary energy change happening is from chemical to light. Good. Steam engine is what? Steam engine, they use coal. Yes. So what do they do? It's a chemical to mechanical. Chemical to mechanical. Rajan exerts a force 150 Newton in pulling a cart at a constant speed 10 meter per second. Calculate the power exerted. I know that the power exerted is force times the speed. The force he is applying is 150 newtons and speed is 10 meter per second. It comes out to be 1500 Newton meter per second, which is 1500 watt. I hope this is something that I have discussed in this video itself. Yeah, if you want to know the formal derivation, please go over the theory lecture again. Let's move ahead. Name a physical quantity measured in terms of horsepower. There is power right in the answer, right? The physical quantity mentioned is power. It's the rate of work being done. A nut is opened by a wrench of length 20 centimeters. If the least force required is 2, find the moment of force needed to loosen the nut. Right? So they are saying that there is a nut and there is a wrench and there is a wrench. Right? The wrench has a length of 20 centimeters. If the least force required is 2, the least force, what do you mean by least force? We all know that the least force will be required when you are applying the force at the end of the wrench, perpendicular to the handle. Yes, find the moment of force needed to loosen the nut. What is the moment of force? Moment of force is defined as, the torque is defined as force times the distance between what? The line of action of the force and the point of rotation, which is 20 centimeters. So the moment of a force needed to loosen the nut is what? Force is 2 newtons times 20 centimeter. It comes out to be 40 Newton centimeter. I hope I am clear. It is a revision of the first chapter. Yes. Briefly explain why the work done by a fielder when he takes a catch in a cricket match is negative. This is something that you should explain yourself. How? We know that when a catch is taken, the ball is coming. Yeah. When a fielder tries to grab the ball, the hand moves back. The hand moves back or downwards. So the force is being applied to stop the ball. The force is applied by the fielder to stop the ball, but the displacement is happening in the opposite direction. Yes, I hope you are able to visualize that when a fielder is catching the ball, what's happening? His hand comes down, but the force on the ball is being applied in the opposite direction. So the work done is negative. Why? Because the force and displacement are in the opposite direction. Yeah, please articulate it properly and write it in your own words. And now there are a couple of questions which I thought to be important in the context of board examination. A pump is used to lift 1000 kg of water from a depth of 90 meters in 10 kgs in 10 seconds. Calculate the work done by the pump. What is the work done by the pump? The work done is the force applied. What is the force applied? It is the weight of the water. What is the weight of the water? 1000 times gravity is the force done, and displacement is 90 meters. Yeah, so I hope it's clear. There is a well. Let's say there is a well, and the depth is 90 meters. There is a pump attached here. The pump is getting water up against the force of gravity and delivering it to the field. There's a field here. Yeah, so the displacement is 90 meters. Yeah, and what is the force of being applied by the pump? It is to carry the weight of the water. The weight of the water is the force. So weight of the water is 1000 times G times 90. We'll take G to be 10 meter per second square. So it comes out to be 1000 times 10 times 90. What? Kg meter per second square times meter. We get it to be 900,000 Newton meter. I hope I'm clear. Power at which the pump works. So the power delivered by the pump is what? The work done per unit time. The work done is 900,000 Newton meter. In what time? In time period of 10 seconds. I get it to be 90,000 Newton meter per second, which is watt. Yes, I hope I'm clear. Now they are saying the power rating of the pump, if its efficiency is 60%. So what they are trying to say is that the power of the pump that you see here is only 60% of what its total capacity is. Let me repeat it. When I say that the efficiency is 60%, what do I mean by that? The power developed by the pump in real life while doing work is 60% of its capacity. So I know the power delivered by power actual, which is the power rating. Power delivered by power rating is equal to 60%. Percent is 60 upon 100. Yes, I know that the power delivered is 90,000 watt. I just calculated it. Yeah, so the power rating, it is power delivered, that is 90,000 times 100 divided by 60 times 100 divided by 60. I hope I'm clear. So the power rating of the pump is it is 150,000 watt. I hope I'm clear. Yeah, so whenever you buy a device, there is a power rating mentioned on it, right? The power rating of that it will deliver. And there is an efficiency mentioned. There's an efficiency means that much percent of the power rating is what you can expect the machine to work, because in real life there are so many losses, so many energy losses happening, right? So I hope I'm clear. If not, please go over this video again, this question again. Yeah, draw a diagram to show the energy changes in an oscillating simple pendulum. Indicate in the diagram how the total mechanical energy in it remains constant during the oscillation. Please go over my theory video, theory on work, power and energy. It's the video just before this in the playlist. Please go over it. I have solved this in detail. It is very important in the context of the board examinations. Yes, let's move ahead. Okay, the last question. It may be a challenge for a few of you. Let's see. A bullet of mass 0.5 kg. Bullet of mass 0.5 kg strikes a wooden target. There is a wooden target somewhere here. There is a wooden target and the bullet is moving. Thickness of the target is 0.2 meters with a velocity of 300 meters per second. Before striking, the speed was 300 meters per second. Yes, and emerges out with a velocity of 100 meters per second. So after it comes out, the speed is what? Let's say V, it's 100 meters per second. Calculate the loss in kinetic energy. Calculate the loss in kinetic energy. How do I do it? It's very simple, no? So the loss in kinetic energy is what? Whatever it was earlier, the initial kinetic energy minus the final kinetic energy. They are asking the loss, right? So the kinetic energy has decreased. So initial minus final, it is what? Half m. Initial velocity is u squared minus half m v squared. The final velocity is v squared. So it is half times the mass. What is mass? Mass is 0.5 kgs. U squared is 300 squared minus v squared, 100 squared joules. Can I calculate it? Yes, I can. So it is half times 0.5. It is 9. Comes out to be 80,000 upon 4 joule. It is 20,000 joules. The loss in kinetic energy is 20,000 joules. The loss in kinetic energy is 20,000 joules. I hope I'm clear. Average force of friction by the wood. Average force of friction by the wood. Acha, what is the loss in kinetic energy? How is it happening? How is the loss in kinetic energy happening? There is a resistive force. There is a resistive force that is applied by the wood. Let's say that the force, which is the force of friction, is what? F. Let's say it. Yeah. So the work done on the bullet by the force of friction is what? Is the force F. And the displacement. The displacement is the bullet is traveling from this end to that end. That is the duration in which the force is acting on it. So displacement is 0.2 meters. 0.2 meters, but in the opposite direction. So the negative force. Yes. Now I know that the work done on an object is what? The change in kinetic energy, which is kinetic energy final minus kinetic energy initial. Work done by the friction is minus F times 0.2 meter. Kinetic energy final minus initial, I know it is minus 20,000 joules. Why? Because I know kinetic energy initial minus final. Final minus initial will be negative because the final is lesser. Correct? So this minus gets cancelled and force comes out to be 100,000 newtons. I hope you can calculate it. I hope you can calculate it. Yeah. So what did I do? I know that why does the bullet decrease its speed? That means there must be some force acting on it, decreasing its speed. Yes, and by the work energy theorem, I know that the work done on the bullet by the friction force has to be equal to the change in its kinetic energy. Has to be equal to the change in its kinetic energy, and by equating the both of them, I have found out the force, the average force of friction of wood to be 100,000. I hope I'm clear. What did I use? I used the definition of force of work done. What is the work done? It is force and displacement. I know that the force is being applied opposite to direction of displacement. Why? Because it is stopping, right? The wood doesn't want the bullet to pass through it, so it resists it. The force is in the opposite direction, and work done is negative. I hope I am clear. I hope I'm clear. Yes, thank you so much, everyone. That is all for this video, and this video covers all the important topics for ICSE 2026, and please go over it, and you will be fully prepared for the examination once you have fully understood all that I have discussed in the lecture and have articulated it in your own words. Yes, thank you so much. If you have any doubts, please feel free to ask it in the comment section or when you meet me physically in class. Thank you so much.